Why we use the sun to test Earth's shape. I'm Corey Kell, creator of FlatEarthIntel.com, and today we're going to talk about why we use the sun. Basically, it's Orbital Mechanics 101. Sun position is very important because in the globe model, we're said to have been orbiting the sun. That's why we'd want to use the sun to test Earth's true surface shape. The other reason is because the sun is always 90 degrees in both models, both the flat Earth model and the globe model. The only difference is or some of the different aspects is that the globe model tilts to get the sun at 90 degrees, whereas the sun is orbiting over the top of the flat Earth model. But the sun is always, always, always 90 degrees in both models. And that's why we'd want to use the sun. Again, we're testing the model in the orbital mechanics in the globe model. That sun position is very important. So all we have to do is basically break down the model in sectors of 45 degrees. And how we do that for the globe model, we can do that by latitude and longitude. Very easy. We have a breakdown here of each of these latitude and longitude squares are 10 degrees. So what we're going to do is during the 45 degree sector test, we want to be 4.5 grid squares from our position at the OS, the azimuth direction, the sun's position during we'll say the summer solstice up in the northern hemisphere at the Tropic of Cancer. We know that sun's exact position. So for our position at the OS, 4.5 grid squares or 45 degrees, this is our position to the sun at 45 degrees. So it's very simple. Again, you have to remember that these are concentrical rings, or these are rings around the globe model. And I know a lot of people say, well, the globe isn't a perfect sphere. Well, the best case scenario for the globe is that it is a perfect sphere. The worst case scenario for the globe is that it's not a perfect sphere. Because why? Because this thing is spinning, and spinning will work against it. And again, motion also works against testing this model as well. So there are a lot of faults with this globe model. Once we start breaking it down, we can find out. Why we want to use 45 degrees is very simple. 45, if you're 45 degrees, the sun can only be a maximum height of 45 degrees. That equals 90, 45 and 45. It's different for the globe, for the flat Earth model, because on the flat Earth model, our level is, or our angle to the sun is 0 degrees. So we can go all the way up to 90 degrees for our reading. So again, very, very easy to do once we learn it. Something we should have learned in our traditional education, but weren't. And again, this is Orbital Mechanics 101. This is how we figure out our 45 degree angle. And all we're doing is we're checking our position from the OS to our sun's position in the tropics. And again, these grid squares, each one contain are 10 degrees, 10 by 10. If you go 4.5 grid squares to the sun's location in the tropics and a certain time of year, you are 45 degrees. That's why it's called the 45 degree sector test. Very basic, very simple. In that 45 degrees, you only have 45 degrees vertical angle measurement. It's kind of like the rocking chair, or Granny in the rocking chair. If we look at Granny here in the rocking chair, we see that Granny is on a flat surface or a level surface. She is level with that picture, that line of sight, that vertical angle measurement. If we angle Granny at a 45 degree angle to that object, we can see that the normal motion from our picture, it drops. So again, this is the effect of angle, what the angle does at a curved surface. And this is why for the 45 degree sector test, if you're at a different angle for the globe model, if you're 45 degrees, that sun has to be 45 degrees or less at a certain period, or azimuth, sun plot azimuth to the sun at its sun position. Again, timing, there are two types of timing, which one is sun plot and the other is time set. For the FE model, Granny's level, she's at 0 degrees, so she has a lot of room to work with on vertical angle measurement. So again, that's just basically simple how it works. And again, we look at our times. Our westerly reading is going to be 3 to 4 p.m. in the afternoon, and then the following day at easterly reading at 9 to 10 a.m. in the morning. Again, very simple. We can break down that globe model. It's simple math. If you're 45 degrees to an object, 45 and 45 equals what? 90. That's the limit. It's very simple. Doesn't get you any easier than that. And again, for vertical angle, the higher you go up, once you get above 45 degrees in the 45 degree sector test, and here we have a vertical, or measuring a vertical angle to the sun. This is a digital protractor at the very end of it. and that's our sun, you can only go up 45 degrees to reach that limit for the globe model. If you're up in the 46 to 50 or more, you're in flat Earth model territory only. The globe cannot achieve that reading. So again, you have to know the limit. And this is how I developed a 45 degree sector. It was developed from artillery live fire safety boxes. And here we have a simple geometric form, a kill box, which is a safety box. When we have two positions for the sun. When we test the globe model, we're getting alignment, our linear manual alignment from our OS. We're going to test that globe model, whether we're using time set or sun plot method. And all we're doing is that sun, this is time set, sun position 2. We get that vertical angle measurement from the OS as shown here, the height of the sun. If it's you're at 45 degrees, 3 hours, or 45 degrees from a sun plot, the position from the OS to the sun's position in the tropics at 90 degrees, that you can only achieve a 45 degree vertical angle reading to the sun at sun position 2. Very simple. When we put the test of the globe model, 133 tests, it failed 76 of those tests for a 57% failure rate. Again, massive geometric failure for the globe model on both sides of the terrestrial Earth. When we tested the flat Earth model, we applied those readings for the flat Earth. Flat Earth has a huge advantage in vertical angle because you're measuring from 0 degrees. You're on a flat surface. Therefore, you can get a reading well over 45 degrees. Again, flat Earth testing out of 133 passed all testing 100%. And that's the standard. That's the standard for the testing, is 100% pass rate. Again, very easy to do. But yet, a lot of folks were never taught this. We're never taught it in our traditional education. And again, that's just simply how it works. It's very basic, very simple. Testing Earth's true surface shape, the results, as I said, there were over 130 tests from both sides of the terrestrial Earth, Afghanistan and Asia, North Carolina, and North America. 4 out of the 8 total 45 degree sector tests failed for the globe model for 100% failure rate of all 4 areas that it failed. The flat Earth model passed all testing to date. Orbital mechanics for the globe model fails using the sun being the principal object for the globe model is said to be orbiting. So it's massive, massive geometric failure. And again, Operation Resolute time, 87 tests, 50 of those failed. And right at about a 57-58% failure rate. Sectors 1 and Sector 8 failing over in Western Asia. Operation North American Sun, total tests 46, 26 of those globe model failures. 45 degree sectors 1 and 8 again failing. Also, it failed at long distance and short distance testing as well for a 56% failure rate. Again, what we learned from testing the globe model having massive geometric failure, even when given major advantages of high altitude, again, huge problem. Major advantage over 5,000 feet, over a mile high. Declination, when we tested it against declination here in the United States, Operation North American Sun, didn't help it. We applied a heavier declination, 9 degrees westerly. Still couldn't pass. Still couldn't pass the test. And again, this is huge geometric failure. Again, what we also found out is sometimes, certain times of the year, the sun travels faster over the Pacific Ocean. And again, that could be due to evaporation and having less evaporation in the oceans. They might want the sun to move faster over that. Again, just something that we noticed. The globe also failed long and short distance range testing, as well as the 45 degree sectors in Operation North American Sun. So we varied some of the testing as well. This concludes this presentation. I'm Corey Kell, creator of FlatEarthIntel.com, Why We Use the Sun, Orbital Mechanics 101. Thanks for watching.